Okay, hello everyone. My name is Brandon Chesson. Today is April 22nd, 2020. And I did case numbers 1 and 4. So I'll just get right into it. For my number 1 case, it asked, what is the rationale for this mechanism? What other pathways may cancer cells be diverting substrate to? So the enzyme activity of pyruvate kinase is regulated by both metabolites and intercellular signaling pathways. Pyruvate kinase integrates metabolic inputs and signaling to modulate glucose according to the requirement of cells. The pyruvate kinase activity is reduced by phosphoserine, I totally just butchered that, growth signaling. Pyruvate kinase activity is reduced only when growth signaling is active in the cell. It effectively coordinates glucose metabolism with tyrosine-mediated signaling. The activity of this enzyme can also be reduced by the oxidation of cis-358 by ROS. So under nutrient-depleted conditions, the acetylation, probably butchered that too, of K305 leads to a lower affinity of pyruvate kinase. And the second part of that for case number 1 is the key enzyme is cancer metabolism. Most cancer cells have increased expression of PKM2, and rapidly proliferating cells like embryonic and adult stem cells, MYC increases the expression of glucose transports 1 and PMK2, thereby promoting the Warburg effect. MYC is the oncogenic transcription factor, which is overexpressed in cancer cells. The MYC is associated with the promotion of RNA splicing for the expression of PKM2, which is linked with proliferating cells. MYC is thought to induce the expression of splicing factors like PTB. RNA-PA1 that favors splicing of PKM2 over PKM1. MYC stimulates glucose uptake and glycolysis. I can't talk today. MYC also induces glutamine consumption and metabolism, which appears to be important in glucose or oxygen-deprived conditions. As for number 4, for the case 4, the main question on there was, based on the information above, which of the following is the most likely diagnosis of this patient? And so the options were hereditary fructose intolerance, galactosemia, glycogen storage disease, glucose 6-phosphate dehydrogenase deficiency. The answer I chose was the glycogen storage disease, which was C, because epinephrine raises glucose levels in the blood. So let's see if I can do that again. Epinephrine, I keep wanting to say ephedrine, is that bad? Epinephrine plays a role in fight or flight mode by supplying blood to muscles and stimulates the release of lactate. For the given condition, there's no increase in glucose level, but blood lactate levels increases. And in glycogen storage diseases, there are a deficiency of enzyme glucose 6-phosphatase, which is an enzyme found mainly in the liver and the kidneys, plays a vital role in providing glucose during starvation conditions. So as the baby is unable to maintain blood glucose level during the fasting, and this indicates that there is something defective in the enzyme function. This enzyme cleaves glycogen to glucose, thus leading to hypoglycemia or low blood sugar, and lactate formation, conditions indicating that the baby would be unable to maintain the sugar level but produces lactate due to epinephrine. So the physical symptoms would include like the swollen belly because of the enlarged liver. So those are my answers for the 2 cases that I chose. So good luck to everyone, and let me know what you think.